All right. Hello, everyone. Welcome back. So today we are going to be doing our EQAO math practice for academic measurement. So a lot of this, again, is going to be the same materials that we learned in the last unit in terms of, volume, surface area, those kinds of things are going to come up here. Okay. So we're going to go ahead and go through these. And this will also help you practice for your final exam and for the EQAO. So let's get into it. The first question says, the figure pictured below is made up of a cone on top of a cylinder. The cylinder has a volume of 96 centimeters cubed. Oh, what is the volume of the figure in total? Okay, so here's the thing. We know that the volume of a cone with the same base and the same height, right? The same area of the base and the same height, so the same radius and height, is going to be a third of the volume of the cylinder. So all we must do here is do 96 divided by 3 to get that the volume of the cone is 32 cubic centimeters. And they want the volume of the figure in all. So they want the 96 centimeters cubed plus 32 centimeters cubed. And as we notice, all the answers are above 96 centimeters cubed because we know it has to be at least that since part of the figure is already at 96. So 96 plus 32 gives us 128 centimeters cubed. And therefore, that's going to be our answer. It's going to be B. Okay, we actually did a whole lesson about that previously, just talking about this topic and pointing out how the volume of a cylinder is actually 3 times that of the respective cone with the same dimensions. Good. Okay, let's move on to number 2. It says the following is the formula for the area of a circle. Area equals pi r squared. If the radius of a circle is 1.25 centimeters, which is closest to its area? So let's figure that out. Let's do area is equal to pi r squared. In this case, r is 1.25 squared. So that's going to be, let's see, 1.25 squared is 1.5625, and that's times pi, 3.141592, which is 4.91, right? Approximately, if we round to 2 decimal points. Now, that is extremely close to 4.9 centimeters squared. So I'm going to say that they just rounded to 1 decimal instead of 2 as I did. And I'm going to go with C because C is much closer than the other values. The reason they're asking what's closest to its area is not really to test, how well can we measure, the difference between various things. It's more because whenever we have pi involved, it's never going to be an exact answer. It's always going to be an approximate answer as soon as we forego pi and replace it with the pi button on our calculator. We're always going to end up rounding off at the end, or some calculators truncate as well. It just depends. But the long and short of it is, as the second that we punch the pi button into our calculator, we're getting an approximation and not an exact value anymore. So that's why they worded the question this way. Okay, let's move on to number 3. Number 3 says, Mark has a garden that is made up of 3 square sections. He builds a fence on one side of the garden, as shown on the right. Which of the following is closest to the length of the fence? Okay, so we want to find the length of the fence. So to do that, what we must do is we must take the square root of each of the areas, right? If we take the square root of a square, we get one of the side lengths. And then if we add up all those side lengths, we will get the length of the fence in all. So let's grab our calculator and let's find the square root of 11.56. And that's going to be 3.4 for this one. Okay, what about for the next one? 6.76, the square root of that is 2.6. And then for the last one, it's 21.16. The square root is 4.6. So if we add those up, if we add up 3.4 meters plus 2.6 meters plus 4.6 meters, that's going to be equal to 10.6 meters. And that is going to be 10. Or sorry, that is going to be B. So there we go. All right, number 4. The 5 kilometers of the highway between City X and City Y is closed. There are 2 possible detour routes. One through town A and one through town B. Oh, well, looks like going through town B is probably going to be a much better deal. How much shorter is the detour through town B than the detour through town A? Okay, well, that's where it gets harder. At first, I thought maybe they'd just ask which one was shorter, and clearly town B looks like it's a lot shorter. So the detour through town A looks like a pretty big waste of time, if you ask me, unless you like town A a lot better for some reason. But yeah, let's see. So let's take a look at, first of all, the detour through town A and what that would look like. So by Pythagoras' theorem, we could say that 5 squared plus, and let's just label this x. Okay, let's make up our own variable here. 5 squared plus 12 squared is equal to x squared. That would mean x squared is going to be 169, and therefore x is 13. So this is going to be 13 kilometers. So therefore, the total detour through town A, so town A detour, would be 12 kilometers plus 13 kilometers, which is 25 kilometers in all. Now, what about the next one here? We're going to use Pythagoras' theorem again, except this time 5 is our hypotenuse for the detour for town B. We're going to just label this side y and find it. So here we have 5 squared minus 3 squared is going to equal to y squared, which means y squared is going to be equal to 16, which means y is equal to 4. So y is 4 kilometers. 4 kilometers. So therefore, the detour through town B, the town B detour, is going to be 4 plus 3 kilometers. So that's only 7 kilometers. So it's way shorter. Now they're asking for the difference, right? How much shorter is the detour through town B compared to town A? Well, that would be 25 minus 7, which is going to be 18 kilometers. So basically, we can save ourselves from driving an extra 18 kilometers by going through town B. And honestly, the town B detour is not too bad. It's only an extra 2 kilometers from the original route that we'd take to get from City X to City Y anyway. So not bad at all. All right, well, there we have it. Let's do number 5 next. So number 5 says the sign, right, is made up of a rectangle and a semicircle. Which of the following is closest to the area of the sign? Okay, so there's 2 parts here. We've got to find the area of the semicircle and the area of the rectangle. So the area of the rectangle is base times height, or length times width, whichever you prefer, which is 30 times 10, which is 300, right? 300, which is excellent. Very good. And there we go. Awesome. Okay, now what about the semicircle? Okay, so we know that the area of a circle is pi r squared, right? That's what we know. Now, what about the area of a semicircle? That would be half of the area of the full circle. So that would be pi r squared divided by 2. So in this case, pi times 15 squared divided by 2. That is going to be, let's see, what's 15 squared divided by 2? And then times that by pi. That's going to be about 353.4 approximately, right? And that's why they, because pi is in the mix here, that's why they said which is the closest, because we know that as soon as we add pi, as soon as we involve pi, we're going off of approximations here. So now we've got to add both areas, the area of the semicircle and the area of the rectangle, because both are part of this sign to find the total area. And if we do that, we'll get 653.4 cubic centimeters, square centimeters, not cubic centimeters. My apologies, square centimeters, because it's area, not volume. And that is very, very, very close, if we just round to the nearest whole number, to B, which is 653 square centimeters. So there we go. Okay. This next one says, the container pictured below is made up of a cylinder and a cone. The cone and cylinder have the same height. Which of the following is closest to the volume of the container in total? Okay, so first of all, if they have the same height and the total height of both is 40, that means the height individually for each one is 20, right? And since the diameter is 12, that means the radius is 6. So now what I'm going to do is I'm going to find the volume of the cylinder and the volume of the cone. So let's find the volume of a cylinder first. That is going to be pi r squared h, which is going to be pi 6 squared times 20, which is going to be, let's see, 6 times 6 times 20 is 720. So 720 pi, which is going to be approximately 2,262 if we round to the nearest whole number, which looks like that's what they're doing here. They're rounding to the nearest whole number. Okay, awesome. And now the volume of a cone is the same as the volume of the cylinder divided by 3, right? Because the cylinder and the cone both have the same height and radius. So we could plug in the regular equation and do pi r squared h over 3, or we could just divide by 3. So I'm just going to do that. I'm just going to divide 2,262 over 3. And I'm going to get 754. So therefore, the total volume is going to be equal to 2,262 plus 754 for the full container. And that's going to be 3,016 cubic, this time it is cubic centimeters. And that is one of our answers. That is answer B. So we'll choose B. Very good. Awesome. Okay, let's move on to a couple open response questions here. The first one says, skate on. A diagram of a community ice rink is shown below. The rink is enclosed with fencing that costs $6.20 per meter. Determine the total cost of the fencing. Okay. All right, so let's do that. All right, well, this is an interesting question here. Okay, so what we're going to do here is we're going to say, well, we know this is 26, right? This full thing is 26. So that means half of it, which is our radius, is going to be how much? 13, right? So this is going to be 13. And what does that mean? That means that this distance from here to here, which is also our radius, is also 13. So that means in terms of how long like these sides of our rectangular-ish type of rink are is going to be 61 minus 13. Okay, so let's do that. 61 minus 13 is going to be 48 meters. Okay, and same with this side, we have 48 meters over here as well. Okay, awesome. Now we also need to know how much, what is the circumference of this semicircle? Well, we know that the circumference of a circle is pi 2r, right? So 2 pi r is the circumference of a full circle. So of a semicircle, it would be 2 pi r over 2, which is just pi r. So that would just be pi times 13 in this case, which is going to be about 41 approximately. Did they tell us? Let's just do 40.84. I think that's a good enough approximation for that part. So that's how much the circumference of the semicircle is. Now we need to add that circumference, the 40.84, to all the other ones. So plus 48 plus another 48 for these two sides, right? Plus this side here, which is 26 meters. So let's add all those together to find out the total amount of meters of fencing. So that's 40.84 plus 48 plus 48 plus 26, which is 162.84 meters. Now it says the rink costs $6.20 per meter. So to find the cost would be 162.84 times $6.20 for each meter, which is in total going to be $1,009.61. And so the total cost of fencing for the rink would be $1,009.61. Very good. Okay, this next one says cutting cones. It's hard to see this question. I kind of wrote over the last one. There we go. Okay. The figure pictured below is a cone with its top portion removed. Determine the volume of this figure and show your work. Okay, so how we're going to do this is we're going to find the volume of the full cone, assuming that the little part at the top hasn't been removed. And then we're going to find the volume of this, that has been removed, and we're going to subtract it off of the total. And that's how we're going to solve this. So let's do the volume of the full cone. We'll put FC for full cone, is going to be pi r squared h over 3, which is going to be, well, let's see. What's the radius here? Looks like the diameter is 8, so the radius is 4. Pi 4 squared times our height, which the full height here is 12 centimeters. So that's what we're going to use. We're not going to use the 9. We're going to use the full one because right now we're finding the volume of the full thing. The 9 will come in handy later, but for now we're using the 12. We're pretending that nothing's been chopped off yet. Okay, then let's figure it out. 16 times 12 divided by 3 times pi is about 201. Okay, so total it's 201 centimeters. Now I'm going to find the volume of the chopped part. So the top, or we'll do TP for top portion, because that's what that's a language they use in the example. So I'm just going to use the same language they did. So what's the volume of the top portion? That's going to be pi r squared h over 3 again. But this time we're going to use this radius, which is 1. And we're going to use this height, what's this height? Well, if the height from here to here is 9, and the full height is 12, that means this height must be 3 centimeters. So we'll use 3 centimeters here over 3. So the answer here is actually just going to be pi, right? These 3's cancel out. 1 squared is just 1, so the answer is going to be 3.14159, etc. centimeters. I'm just going to stop at 3.14 though, just to be approximate there. And then to find the volume of the figure, we must subtract them. We must do VFC minus V of the top portion, so the full volume of the full cone minus the volume of that top portion would be, is going to give us looks like about 198 approximately. So approximately 198 if we are rounding to the nearest centimeter. So 198 centimeters. Oh, and I should be putting cubes here. My apologies for not earlier, because these are all cubic centimeters because we're calculating volumes here. Very good. All right, well, that is everything for the measurement part of the EQAO preparation. I hope you learned a lot from this, and I do hope too that this kind of reinforces not only the skills you need for EQAO, but also skills that we learned in general in this course, because that's always the goal too, is to kind of tie this in with other things we've done in this course. But yeah, that is it for today. Good work today, everyone, and we'll see you next day. Bye, everyone.